And we're back. So we have got part C of that question. The director of a health clinic wants to reduce waiting times. They want 95% of patients at least to be seen by a doctor within 45 minutes. And we've got a mean time unchanged at 34, and standard deviation is going to get affected. So the previous mean and standard deviation values are going to be relevant again in this part of the question. So previously mu was 34 and it's staying the same, and previously sigma was 8. Now they're saying that what they want to have happen here is that standard deviation is going to reduce by 4 minutes, 0.4 minutes for each additional doctor employed. We're going to say that there are n doctors employed. So we're going to take off 0.4 for each of those. 45 minutes is the target time they're aiming for, and they want 95% or more people seen in that 45-minute time gap. So we're back to Z tables again. So we're going to have to set up our Z value formula. Now the actual Z value is accessible to us because we've got this 95% or 0.95 of the area underneath the standard deviation. So we'll go to our Z tables and look that up. And the closest we can get is 1.65. So a Z value of 1.65 gives us a shaded area of 0.95. And we'll fill in the rest of the values into the formula. And then it's just a question of getting n by itself. So a little bit of tidying up. So I'm getting a value of n equals 3.3. Now the thing is, I can't have 3 and a bit doctors, and I clearly need more than 3 in order to achieve my goal. So I'm going to have to round this up to 4 doctors. And that's part C completed. On to part D, last bit. So in part D, there's more research going on, and it's found that the proportion of patients in our sample aged 60 years or more is calculated, and there's also information about the radius of the confidence interval. So a couple of things to watch out for here. First of all, we see mention of proportion of the sample and population proportion. So this is P and P hat that we're seeing. We're also seeing talk about the radius of the confidence interval. This is just another way of talking about the margin of error. If we briefly visualize our confidence interval with our population proportion in the middle and our highest and lowest values calculated by p hat minus the error and p hat plus the error, you can see it looks a little bit like the diameter of a circle. And so the radius of the actual confidence interval is just the exact same as the margin of error. It's just that bit that you've gone down and gone up from P in order to get to the end points of your confidence interval. So when we look up the formula for our standard error of the population in the log tables, we get root P bracket 1 minus P over N. Timesing that by 1.96 gets our margin of error. Bear in mind, we have discussed in the past how P and P hat are kind of fairly interchangeable depending on what's being discussed in the question. In this particular question, they want to know the number of patients in the sample. So P hat refers to the sample, so we're going to stick in P hat in these positions. Now, we don't know what this P hat is. This is what we're trying to figure out. We do, however, know the value for N because we're referring back to the same sample as in the previous part, or possibly in part B even. So we were told in that part that N was equal to 100. That was the size of our sample. So we can fill that in. And we're going to let that margin of error, or that radius of the confidence interval, if you like, be equal to 0.09408. Now, I'm not just making that up. That's coming from my percentage up here. I've just written it as a decimal. And I'm going to try and isolate p hat now out of this. So a little bit of a tidy up. I'm going to distribute the square root over the numerator and denominator of the fraction. And I'm going to bring that 1.96 across and divide. So we're getting 0.48 for that. I don't want there to be the square root there, so I'll square both sides. And I'll do a bit more of a tidy up. And actually what I'm going to find is that this is going to turn into a quadratic. So I'll just get everything over to one side equal to 0. And I'm then going to use that to get two values for p hat, which makes sense because they're talking about a smallest number and a largest number up here. So I'm expecting that there should be two possible solutions. Clearly, it's going to be a minus b job on the formula. So I'm going to assume we can all do minus b, and I'm going to just jump to the end of that for the values. And this is the proportion of the sample that I'm after finding. But of course, my sample had a size of 100. And what they're asking me to find is the smallest number and the largest number of patients. So what I'm actually going to do is just multiply these proportions by 100 to get that answer. So one answer is 64 and the other is 36.